All right, on page 52. The problem is to check your understanding. The abbreviation for that is always CYU. Part A. Who feels that they got part A?
P equals 12n minus 200.
Good. And we did have an example problem that we went over in class with this. This one says, students and parents who attend the Banneker High School Take a Chance Carnival Night spend an average of $12 per person. As soon as I come to a number, I should write that down. $12 per person. Operation of the event costs the student government $200. That's the cost to run the event. Yeah, I've made myself kind of a little glossary here of what all the numbers mean. What is the relationship between P, the profit? P, that's profit. Now I know what my variable stands for. And N. The number who attend. There we go. When I put it all together, I should be able to see that I find the profit by calculating $12 times the number of people that come, and the amount that it costs them to run is $200. Profit, you'll remember, equals income minus expenses. And there we go. That's the answer. They didn't want you to solve this equation. Don't worry, we'll do plenty of that. What we're just trying to learn how to do here is take a situation in words and turn it into an equation. Because then we can use that equation for stuff. We can make tables and graphs with the equation. We can find any values. For example, how many people would have to come for them to break even. We don't need to worry about it now. But if their goal was to make a profit of $1,000, how many tickets would they have to sell? The figure drawn below is the isosceles triangle with KL equal to KM. I'm not going to draw the triangle. What the heck? I'll attempt to draw the triangle. K, L, and M. And then we took some measurements. Use a ruler to make measurements from which you can estimate the perimeter. How do you find the perimeter of a triangle? What's the perimeter, Amber?
You measure two of the sides because two of the sides are equal, so you just measure.
KL equals LM. Good.
And then you measure the bottom one, and then you add them all together.
For KL, I got 3 1/4 inches, 3.25. Does that seem about right to you? Okay? If you got 3 or if you got 4, that's okay. It'll still work out. And then you added to that the bottom one, which was 5. And then you can calculate that. You get 6.5 plus 5. The perimeter is 11.5. It says estimate, even though you're measuring it, because you can round off. The difference between 3.2 and 3.25 inches is pretty insignificant at this point. But what about the area? Anybody else besides Amber know how to calculate the area? I'll come back to you, Amber, if nobody else gets it. Jeremy, what do you think?
Isn't it half base times height?
Exactly. Base times height. Now we made, this was 3.5, this was 3.5, and that was 5. Which of those, Jeremy, is the height? The 3.5 or the 5?
3.5. No, the 5.
9.
Neither.
No, it's the highest.
It's neither. What is it, Caitlin?
It's the highest point in the shape.
It's the highest point here?
Yeah.
Make a dot.
Down like that. Make it dotted? You could definitely make it a dotted line. 1/2 base times height. Like he was just saying, like Caitlin and Jeremy were just talking about, from the top to down here, you'd have to measure that as well. What did you get when you did that? I don't suppose anybody would have used the Pythagorean theorem to find that. You could. You just use a ruler. What did you get, Christina? 2 1/4. I'll take it. 2.25. So now we can just plug that into a formula. Remember we were talking about independent and dependent variables? The independent ones are the ones that we choose, or measure, or find. Okay? the ones that we have control of. Right now, we've used some measurements to control that we are using a base of 5 and a height of 2.25. When I plug those numbers in here, 1/2 times 5 times 2 1/4, which I can't do in my head. Can somebody do that for me? Thanks. Or you must have it right there on your homework, don't you?
125.
125? I don't think so.
That. Oh, 2.25.
Who's got that number? Amber.
5.625.
And in this class, if you would please, round off to 2 decimal places. Just for convenience, so that we're all doing the same thing. Especially when there's like 11 decimal places on your calculator. There, 2's good. All right, so we've got some actual numbers to look at here. These were the independent variables, the ones that are mixed up in the equation, and those gave us the dependent variable. This is just like the other equations that we've been looking at in the bungee jumper situation or that part A problem that we were just talking about. There's some numbers that we go find or pick values for. We do the math, and that gives us an answer. With part 2 of this was for any isosceles triangle, what's the minimum number of measurements for the perimeter? Amber already jumped to this part when she was telling us the answer at the beginning. She said you only have to measure one of these because the problem tells you that KL equals LM. So for the perimeter, I don't have to measure all 3 sides. I only have to measure 2 of them. There we go. And if I was just finding the area, the number of measurements that I would need would be this across the bottom of the 5 and the height right there, because the formula gives me 1/2 times base times height. I don't even need that number. Part 3, write formulas showing how the measurements you described in part 2 can be used to calculate perimeter and area. Well, we've kind of already done that here. To make a formula for perimeter, perimeter is usually side plus side plus side. But like Amber said, we can group 2 of these together. That these are both side 1. Side 1 plus side 1. Another way to write that is 2 times side 1, and then you add side 3. You never need to worry about the second side. On the other hand, the area formula, to make an area formula for this, it's exactly what's right there. I'll just write it a third way, right here. B and H next to each other is always going to mean B times H. And over 2. Dividing by 2 and multiplying by 1/2, same exact thing. You get the same answer, so it's the same operation earlier. But these formulas, how do you take the information that you're given and the measurements that you made to make formulas out of them? This is how. Trying to build a bridge between the geometric formulas that you're probably familiar with. You've seen perimeter and area before, I know. But the idea here is that the algebra that we're learning now is very closely related to the geometry. Even though they might be in different chapters of the book, it's all the same stuff. It's all math. And you can use all the techniques from one in the other. You'll see a lot of problems when we're dealing with linear equations in the chapter that we do that the linear equations come from the geometry formulas. For example, the circumference of a circle would be an example of that. Any other questions on that homework problem? Okay, thank you very much.